API 650 storage tank construction code or standard. This is for welded tanks for oil storage, and it covers the scope, terms and definitions, design, fabrication, erection, examination, welding, and marking. The following modules would address the topics brought in the body of knowledge regarding API 650, highlighting that what we believe are optional potential exam questions. API 650 standard includes the requirement for material design, fabrication, erection, and transportation for storage tanks in various sizes with internal pressure near atmospheric pressure, but not exceeding the weight of the roof, and maximum design temperature of 93 degrees centigrade, 200 degrees Fahrenheit. The appendices are either normative, mandatory, or informative, recommended. Only normative Appendix L is always required. Other normative references depend on circumstances. For example, Appendix M is only required when operating at high temperatures. Familiarize yourself with API list of contents. This is particularly useful during the open book exam, so you know where to look for. Pay attention to tables and figures. Section 2, normative references. Please familiarize yourself with titles of below important references. 620, low pressure storage tank. 2003, protection against ignition. 2026, safe access egress. DP189 and SNTC TC1A, personal qualification and certification for non-destructive examination, and OSHA 1910, process safety management of highly hazardous chemicals. Section 3, terms and definitions. Some definitions brought here that was not mentioned in other modules. Center line stack. Each shell course may have different thickness than other shell courses. Thickest at the bottom of the lower shell course or first shell courses to account for static head, and thinnest at the top. But the center line of each shell course thickness wise shall coincide. That is, center thickness of shell courses shall be on the same line. Flush stacked on the inside when the inside surfaces of the shell courses coincide. When thickness of all shell courses are same, then it is also center stacked as well. Insert plate. A steel plate not more than 3 mm or 1 by 8 inch. Liners. A protective non-stick or bonded with the plate. Lining. A protective stick or bonded with the plate. Mandatory means compulsory, required by law or purchaser. Nominal thickness, the ordered thickness of the material, including any corrosion allowance. Thermomechanical control process, TMCP, designed to improve the mechanical properties of materials by controlling the hot deformation process in a rolling mill. Materials, the thickness of plate ordered shall not be less than the design thickness. A thinner plate by 0.3 mm or 0.01 inch is acceptable. So you can always only have a lower thickness than by 0.01 inch, not more than that. Maximum thickness of shell plates shall be 45 mm, 1.75 inch. If plates used for flange reinforcements and inserts with a total thickness of over 45 mm, then the plates need to be normalized or quenched, tempered, killed, made to fine grain practice, and impact tested. Table 4.1 talks about maximum permissible alloy content. So that is when you're looking at the mill test report, you compare it with that table. and Table 4.2 is acceptable grades of plate material produced to national standards. Impact testing of plates is required to evaluate the toughness of material. Toughness is the ability of material to absorb energy before fracture. Toughness is also the area under stress strain curve. The tougher the material, the more resistance it has, tolerating defects and crack under stress. Material with good toughness can also remain in ductile phase even at low temperatures. Toughness is measured by Sharpie impact test, which is V-notch type specimen made as per ASTM A370. An impact test shall be performed on 3 specimens with the following conditions. The average value shall not be less than the specified minimum value. Only 1 specimen out of 3 can be less than the specified minimum value, but not less than 2/3 of the minimum value. This means if more than 1 specimen is less than the minimum specified value, or if 1 specimen is less than 2/3 of the minimum specified value, the test is rejected and needs to be done again. Let's look at the example. We have 2 sets of 3 specimens each were Sharpie tested with the following values. Which one is acceptable? So you got set 1, which is 13, 15, and 16, and the required average is 15 feet. And set 2 is 12, 14, 14, with required average of 13. Now set 1, you add all of them, you get the average, and divide by 3, you get the average 14.66. So this value is less than the required average and hence rejected straight away. Set 2, 12, 14, and 14 divided by 3 is 13.33. This value is more than the minimum average value of 13 and hence accepted, even though one of the test results is less than the minimum average but not less than 2/3 of it. So 13 divided by 2/3 is 8.66. So because none of them are less than 8.66, the Sharpie test results, then it satisfied the second requirement as well and it is accepted. Pay particular attention to figure 4.1a, minimum permissible design metal temperature for materials used in tank shell without impact testing. To use this figure, first you need to find out the material group, table 4.4a, material groups. Once you know the material group, go to figure on page 4.7 and 4.8, then identify the point where your material lies, knowing your material thickness and minimum design material temperature. If this point is above the line assigned to the material group, no impact testing required, otherwise you have to impact test it. The figures and subsequent tables are given both in millimeter per inches and degree centigrade and degree Fahrenheit. Tables 4.3a and b show the linear equation for figures 4.1a and b in SI and US units. Now take an example. Material is A516, 70, thickness is 1 inch, mean design material temperature is 20 degree Fahrenheit. Now from table 4.4b material, you can see that A516, 70 is in group 4. Now that we know the group number, we go to figure 4.1b. You can see that the point for 1 inch thickness and MDMT of 40 degree Fahrenheit falls below the line for group 4 material. Hence, impact test is required. If it is asked what is the minimum required value for impact test, you should see table 4.5b, minimum impact test requirement for place. In this case, average impact value of 3 specimen for longitudinal specimen is 30 foot-pound, and for transfer is 20 for thickness less than 1.5 inch. Again, table 4.5a is for metric or SI units, while table 4.5b is for US units. Section 5. Design. Weld sizes for shell and roof openings. Note, for type of welds and weld joints, please see Module 8. Also see figure 5.1, typical vertical shell joints, table 5.1a and b on pages 516 show annular bottom plate thickness versus the first shell course thickness and applied stress. For example, if the first shell course has a thickness of 25 millimeter and applied stress of 225 megapascal, the bottom plate thickness shall be minimum of 7 millimeter. Table 5.2a and b on pages 518 through 521 show permissible plate material versus the allowable stress. For example, A15 516/65 can only have a maximum yield strength of 35,000 psi on its first shell course and a maximum hydrostatic test pressure of 23,500 psi. Please note that this is irrelevant of thickness because we are talking about the strength and stress and not the applied load. Thickness is only important when toughness is also a major player, that is for plate thickness over 2.5 inch. Calculation of thickness by 1 foot method. Use only for tank larger than 200 feet in diameter. For a 1 foot method, calculate the thickness required at the design points 0.3 meter or 1 feet above the bottom of each shell course. For metric or SI units, the formula to calculate design thickness and hydrostatic thicknesses are TD and TT, which is D for design thickness and T for test thickness or hydrostatic test thickness. Different formulas here. As you can see, there is no corrosion allowance for hydrostatic test. Note, thickness in millimeter, but the diameter and height are in meter. For US units, the formula to calculate design thickness and hydrostatic thicknesses are slightly different because the units are different, as you can see here, where TD is the design shell thickness, TT is hydrostatic test shell thickness, D is the nominal tank diameter in meter, H is the design liquid level in meter, G is the specific gravity. For water it is 1, corrosion allowance is CA, and SD is allowable design stress, and ST is allowable hydrostatic test stress. The inspector should be familiar with determining the sizes and spacing of welds for shell opening using the following figures and tables, as you can see here. Please look at these figures, just know where it is, and if a question comes, you can work it out. Minimum spacing between openings and longitudinal weld shall be 8 times the shell thickness or half of the radius of the opening, whichever is less for penetration. Extent of radiography would be 1.5D or 1.5 times of the opening. For post-weld heat treatment, holding time is 600 degrees centigrade or 1100 degrees Fahrenheit for 1 hour per inch. Section 6, fabrication, there is nothing to add. And section 7, erection. Table 7.1 shows minimum preheat temperature versus material thickness and group number. Water filling rate or hydro test is brought in page 7 to 10. 6 sets of settlement readings are required at a half field, a quarter field, a half field, a 3/4 field, after 24 hours, and for fully filled, and then when empty. So that's 6. Repair of defects discovered after the tank has been filled with water for testing shall be made with the water level at least 0.3 meter or 1 feet below any point being repaired. The maximum out of plumbness of the top of the shell relative to the bottom of the shell shall not exceed 1/200 of the total tank height. Out of roundness is measured 1 feet above the bottom corner weld, and the maximum limits versus tank diameter is brought in section 753, page 712. Deviations, picking at vertical weld joint shall not exceed ½ inch for every 36 inch of sweep, and foundation measurements brought in 755, and any possible question shall be in open book section. Section 8, methods of examination. All ND examinations, RT, MT, UT, PT, VT shall be performed as per ASME 5. Radiographic method shows number and location of radiographs depending on thickness. For example, 3 meter or 10 feet of completed vertical joint of each type and thickness welded by each welder or welding operator, and thereafter each additional 30 meter 100 feet. Unit 1 radiograph. Pay attention to figure 8.1, radiographic requirements for tank shells, where it is all summarized and can be referred to during open book exam questions for 3 thickness range. Vertical joints of shell plates greater than 1 inch thick shall be fully radiographed. And then 8134 shows the limit of weld reinforcement under radiography. For example, for a half inch thick plate, the maximum weld crown should be 1.5 millimeter, while for plates thicker than 1 inch, the maximum crown for or weld reinforcement is 3 millimeter. Acceptance criteria for radiography shall be as per UW 51B in Section 8 of ASME Code. If defects found during radiography, 2 additional spot radiographs on either side of the defect shall be taken unless the original radiograph shows at least 3 inches of sound well on one side of the defect, then additional radiograph from that side is not necessary. Magnetic particle examination. Methods of examination as per ASME Section 5. Acceptance criteria as per ASME Section 8. Examiner should be able to read Jaeger type J2 from minimum 12-inch distance. Ultrasonic examination again from ASME 5 and acceptance criteria ASME 8. And examiner shall be certified as level 2 or level 3 ASNT, SNT TC1A. And liquid penetrant, same way, is examination as per ASME 5, acceptance criteria as per ASME 8, and examiner able to read Jaeger J2 from minimum 12-inch radius. Visual examination as per ASME 5, again acceptance as per ASME 8, examiner should be able to read Jaeger J2 from a minimum 12-inch distance and is capable of passing a color contrast test. Examiner shall be eye tested annually. Maximum permissible undercut is 0.4 millimeter, 1/64 inch in depth for vertical butt joints, and 0.8 millimeter, 1/32 inch for horizontal butt joints. Now you can see that vertical joints undergo hoop stress as well, and roughly stress twice that of horizontal joints, and hence the acceptance criteria is more onerous. 852D shows the maximum weld reinforcement. For example, for half-inch thick plate, the maximum weld crown should be 3 mm, while for plates thicker than 1 inch, the maximum weld reinforcement is 6 mm. For horizontal joint, is more onerous for vertical joint. Arc strike discovered in or adjacent to the welded joints shall be repaired by grinding and rewelding as required. Arc strikes repaired by welding shall be ground flush with the plate. Vacuum testing. Vacuum testing is performed using a testing box approximately 6-inch wide by 30-inch long with a clear window in the top. A partial vacuum of 25 kPa to 35 kPa gauge shall be used. The vacuum box test shall have at least 50 mm or 2-inch overlap of previous viewed surface on each application. A minimum light intensity of 1000 lux or 100-foot candle at the point of examination. The metal surface temperature limits shall be between 4 degrees centigrade to 52 or 40 degrees Fahrenheit to 125 degrees Fahrenheit. This is a vacuum box for leak testing of welds in storage tanks. Section 9, Welding Procedure and Welder Qualification. For welding terms and definition, weld types, joint types, welding process, welding inspection, please see our Module 5. For WPS, PQR, WPQ, please see Module 4. Welding procedure for ladder and platform assemblies, handrails, stairways, and other miscellaneous assemblies, but not their attachments to the tank, shall comply with AWS D11 and AWS D1.6 for stainless structures or ASME Section 9. Remember that there should not be attachments to the tank here. The attachment itself is not included. Impact test, WPS for vertical welds with MDMT below 10 degree centigrade or 50 degree Fahrenheit, and WPS for all weld methods with MDMT below -7 degree centigrade, 20 degree Fahrenheit, require impact testing. Minimum impact testing average of 3 specimens. For P number 1, group number 1 material is 20 joule. For P number 1, group number 2 materials 27 joule, and for group number 3 of P number 1 is 34 joule. Welders shall be qualified as per ASME section 9 and assigned a welder number whose identification mark shall be impressed at least every 1 meter or 3 feet of weld. The nameplate letter and numerals shall be at least 4 mm, 5 by 32nd inch high, and include the following information: year of manufacture, construction code such as API 650 and any addendum, material, diameter at height, capacity, maximum liquid level, specific gravity, MDMT, minimum design metal temperature, maximum metal temperature not more than 93 degree centigrade or 200 degree Fahrenheit, otherwise Annex M applies, any post-weld heat treatment or stress relief, name of manufacturer. Here you can see a sample of API 650 nameplate on a storage tank. As you can see, it talks about all the edition, 12th edition, 650, year completed, nominal height, design liquid level, design metal temperature, maximum design temperature, and there is no stress relief here. Purchaser's tank number, constructed by who, material is BSEN 10125 S275 J2, normalized N. Shell course is 7 and designed by this company. Pressure combination factor is nothing, serial number, and then design pressure is atmospheric. Design specific gravity is less than the water, 775 kilogram per meter cube. So the specific gravity will be 0.775. Nominal capacity, so it's relatively a small tank, and nominal diameter is 150 meter, and nominal capacity is actually, no, it's a big tank, it's 2145 meter cube. The nameplate shall be attached to the tank shell adjacent to the manhole. Annex G1, data sheet for any question related to the data sheet. Annex I1 and I2 refer to under tank leak detection and subgrade protection and performance requirement. Annex K1 and K2 provides example of variable design point method, and Annex M1 addresses requirement for API standard 650 tanks with maximum design temperature more than 93 degrees centigrade, 200 degree Fahrenheit, but not exceeding 260 degrees centigrade, 500 degree Fahrenheit because of reduction of yield strength. Annex O1, O2 addresses under bottom connections and settlement. Engineering review is required if the settlement exceeds ½ inch. And Annex S1 addresses austenitic stainless steel storage tank with a maximum design temperature not exceeding 260 degrees centigrade, 500 degree Fahrenheit. That's the end of this module.